The Large Hadron Collider is the most powerful particle smasher ever built. In several stages, it accelerates protons to an energy of 3.5 trillion electron volts, and when it reaches full power in 2014, will whip them up to 7 trillion electron volts. The process begins when a proton is broken out of hydrogen gas. A linear accelerator uses electric fields to send that proton on its way. Then, the proton synchrotron booster uses magnetic fields to steer the proton into a circle, and electric fields to add energy. After that, the proton enters a larger ring, the proton synchrotron, and then an even larger one, the superproton synchrotron. Meanwhile, other protons go through the same process. Finally, they are fed into the main collider ring. Protons circulate in side-by-side pipelines in opposite directions. When physicists flip the switch, magnets steer protons to cross paths inside one of the instruments, and some of them collide. Here, we show one of those instruments, known as ATLAS, which consists of layers of detectors that register different species of particles and their properties. The collisions are extremely messy, because protons are composites of smaller particles. Each proton contains 3 quarks and a number of gluons that bind them together. The collision can occur in a huge number of different ways. In this case, 1 gluon from each proton collides. The reaction produces 2 quarks and 2 gluons, which fly off in 4 separate directions. This is the main collision, also called the hard or short-distance scattering. Physicists traditionally describe it using a Feynman diagram. Then each of the 4 particles decays into other quarks and other gluons, flying in the same direction, producing what physicists call a parton shower. Finally, the quarks and gluons coagulate into composite particles, such as other protons, pions, and kaons, forming what physicists call jets of particles. These are what the detectors actually see. From them, physicists tried to reconstruct the original event.